Hi friends, it's Kamal and you're watching Maths by Jajoria. Please don't forget to subscribe my channel. Okay. In this video, I will explain the equation of a circle and equation of tangent to a circle. So we will discuss these two things here. The equation of circle, I have got circle here. So I have drawn the circle here, and this is your x and y axis in there. Okay. So in the equation of circle, the any point P, so this is P, with coordinates x and y, on the circumference of the circle, so this is the circumference of the circle, can be joined to the center O 0, 0. So this is your center, okay, by the straight line that forms the hypotenuse. So this is what is hypotenuse here. So we can say this is hypotenuse of the right angle triangle with sides of length x and y. So as you know, this is your x. You can say x here, and that's your y, and that is your y here. Okay, and this line hypotenuse we can say is r. Okay, right. This means that using Pythagoras theorem, the equation of the circle with the radius r and center 0 and 0, which is x and y, so both 0, 0, x and y here, 0, 0, is given by the formula. I write down the formula for you. So that is your equation of circle. So that would be x square, yeah, plus y square equal to r square. Okay. Now, I have discussed Pythagoras theorem in my previous videos. So links are there. It's in the playlist as well. So you can use that as well. Okay. Just in case if you haven't watched that, I will recommend you to watch that introduction to Pythagoras theorems, and then you can come to this video. Okay. Now, so this is our formula. Remember this equation of circle. So here, this is your equation of circle. Okay, I highlight that as well. This is we're gonna use a lot, so just remember this, please. Okay. Now, just a quick example on that one. Find the equation of a circle with the radius 3 units and center 0, 0. So this radius here, we just say it's a 3 unit. Okay, and we just need to find the equation of the circle, which is quite straightforward. So here we got the radius r equal to 3. Okay, so your r square would be 9. Okay, from here your equation of circle is x square plus y square equal to 9. Okay, so that will be your equation of circle. Now, because we're going to use the equation of circle in the equation of tangent to the circle, so this is where we need to discuss that in details. So first of all, what is equation of tangent to a circle? So a tangent to a circle, I need to just go like this first. and then bring this as well, so that it will be easier for you. Okay, so first of all, that's the diagrams I got here. So the tangent to a circle at point P with the coordinate x and y. So that is here your tangent here, and that's your circle, and this is your point P. Okay, xy is a straight line that touches the circle at P. So this is your P, and this is tangent is a straight line which just touches the circle here at this point, which is your P point. Now the tangent here is perpendicular to the radius which joins the center of the circle to the point P. Okay, so see here, it says the tangent is perpendicular to the radius. So this is your radius here, right? That's your radius, and this is your tangent. You see, it's a perpendicular to that. Okay, so remember that. Remember this point. This point plays a big role in equation of tangent. So that's your tangent. That's the circle, and this is your radius. Okay. As the tangent is a straight line, the equation of tangent will be of the form y equal to mx plus c. Okay, as I already mentioned that I have covered this in my previous videos, so please watch that as well. We can use perpendicular gradients to find the value of m, then use the value of x and y to find the value of c in the equation. Okay, so just remember this. Okay, this is what we're gonna do. This is what we're gonna achieve when we solve the problem. So in this example, we have the equation. So he says find the equation of the tangent to the circle y square x square plus y square equal to 25. So we have here, this is the circle equation. Okay, and the point has been given to us P, which is 3 and minus 4. Okay, so you see here, this is your x-axis and this is your y-axis. So this is your x. Okay, so it's 3. That's why you got 3 here, and then it's in the minus. So y is minus y. Then you got minus 4 here, and then meet at this point. That's why this point P is 3 and minus 4. Okay, clear so far? Right. Now I'm just gonna come to this now, and let's put this somewhere else. So maybe we can say this. So find the equation of the tangent to the circle at this point. Okay, and I already said the tangent will have an equation in the form y mx plus c. So to find the equation, we need to find the value of m and c, which is already done that. The first step would be to find m, the gradient of the tangent. Okay, so on the diagram here, we have a circle and already explained the tangent at the point 3 and 4, and we got the radius, yeah, from the center, that's your center, to the point P. So if we say that what is the gradient of this, so the gradient of the radius, so this is your radius r. So what will be the gradient of this first? So this is what we need to find out first. Okay, the gradient of radius. So here I write down for you the gradient of the radius is given by, that is, change in y over change in x. Okay, and that is equal to, change in y is what? Your -4. Change in x is your 3. So that is your gradient of radius. Now we need to find the gradient of tangent, which is this. We have gradient of radius here. Now this is the important bit here. Before I go further, I must explain to you this. And that is the radius that joins the center of the circle, which is, let's bring this here so you can see, to the point P at the right angle to the tangent, so that the gradient of tangent is the negative reciprocal of the gradient of the radius. So if the gradient of radius is given to you, the gradient of tangent would be negative and reciprocal. Remember this, right? So that will be, we have here radius, gradient of radius here, and if we have to find gradient of tangent, that will be negative reciprocal, right? So what that would be, so you can say here, and that would be equal to 3/4. Okay, so that will be the gradient of tangent. Reciprocal and negative. Negative will be plus here. So that we got. So from that equation, y equal to mx plus c, we got m here for the equation of tangent, right? I hope it's clear. Now I'm going to move on to the next one, where find the value of c for the point P. Yeah, the value of x equal to, so here we have here what we need to find the value of c, okay, for the point P. Okay, so x here is 3 and the value of y is equal to -4, right, from here. So what we need to do, we need to substitute this value, yeah, as well as the m, which is here, into the formula y equal to mx plus c, okay, from here. Okay, right? And what that will give us. So y we know here, minus 4 equal. So I'm just going to write down now. And we can simplify this step by step. Okay, so what that would be minus 4 equal to 4 plus c. Okay, and what the c would be, that would be minus 25 divided by 4. Okay, so we got c here now. So the equation of the tangent to the circle x square plus y square equal to 25 at the point 3 and 4. Yeah, so this is from here we got, yeah, everything here, x square, this is your circle equation. That would be y equal to, now all you need to do, just substitute the values. So you got m here, which is about 4x, yeah, and then plus you got c, which is in here, minus, yeah, and that will be so that will be the equation of tangent. I hope it's clear that. Very important example. Now I'm going to move on to another example as well. Okay, so that is also very important as well. Sometimes it's you know, they ask you that in exam. So let's bring that. Okay. In this example, find the point where the tangent to the circle, so you have circle here and this is your tangent here, this line is your tangent, okay, it's linear tangent. Circle equation is given by x square plus y square equal to 20 at the point, this point here, 2 and 4 crosses the x-axis. So here what we need to find, the point, this point here. He's saying find the point where the tangent crosses the x-axis. This is what we need to find. Okay. Now that's your y, that's your x. You got your circle. This is your x value here, 2. This is your y, 4. You got the point here, 2 and 4. That's why you got point here, 2 and 4. That's your tangent here. So draw. We have drawn this diagram to show the circle and the tangent at the point 2 and 4. We labeled P as well. Okay, and we draw the radius as well. So this is your radius. Okay, and from the center, this is your center, 0, 0. Okay, center of the circle to the point P. This is your P. So tangent will have again the equation in the form of y equal mx plus c. Okay, so that will be your equation. So first what we need to do, same as we done before, we find m, which is the gradient of the tangent. Okay, so here then we say Find M, the gradient of the tangent. Okay, right. So the gradient of the radius here, so how we find that? First we find the gradient of the radius, because that is given to us here. Okay, so I write here, so gradient of the radius, that will be again same, change in y or change in x. Okay, so that is your change in y, and that is your change in y, which is 4/2, and that is 2. Okay, so the radius, gradient of radius is 2. Now again same thing here, the gradient of tangent is the negative reciprocal of the gradient of the radius. Okay, as we discussed before, right? Right, okay. So if that is the reciprocal of that, that will give us m equal to reciprocal and minus. So reciprocal and minus of 2 is minus half. Okay. Now next thing is to find the value of c. We're talking about here the equation. So let me write down the equation again here. So we got here m here already. So to find the value of c for the point, this point, x is 2 and y is 4. What we do, we substitute this value as well as the value of m as well, we will do into this equation. Yeah, so I just write down here as well, x is equal to, here is 2. Okay, y is equal to 4, and that is from here, point P. That this is your equation. Y is 4, m is your minus, what is your x? X here is 2 plus c, because we need to find c, right? 4, that crosses over, okay, that cancels out, minus 1 plus c. C is equal to 5. C is equal to 5. Okay, so now we got c as well. Okay, so the equation of the tangent, okay, so let's do it here. Yeah, so the equation of the tangent from here would be y equal to minus half x plus 5. Okay, so this what we got. Okay, from here, c, we got c here. Okay, we had your m here, and we got the equation of your tangent. Now, what was the question? The question was, we need to find this point here. Okay, find the point where the tangent to the circle with that equation crosses at x-axis. So this is what we have to find. right? Okay. Now you see the point here where the tangent crosses the x-axis will have a y coordinate 0. Yeah, that's clear. That's your x. X has the value here. However, there is no y. So y would be 0. So once we know that the y is 0 at this here, all we need to do by using this equation, we say y is 0. Yeah. And then the rest we write. Make sense? Yes. Y is 0 here. And with that equation of the tangent, we got y 0. The rest we have already here. Okay. So all we need to do now is to solve this. So this can be written as okay. And then x is equal to 10. So the tangent will cross the x-axis at x is 10, and y value is 0. So that would be your coordinate, 10 and 0. Okay, that will be the answer. So the tangent crosses the x-axis at 10 and 0. So that is your coordinate. Okay, right. So this is more or less this time. Do me a favor, if you are finding this video informative, please like and subscribe this video. As I say again and again, and when you like and subscribe, it just motivates me to make more videos. Be sure to click that like button and drop a comments if you have any question, and I will do my best to reply back to you. Thank you.